Welcome to ThinkData, helping third sector organisations to make better use of data. Find out more at www.thinkdata.org.uk.
Okay, so my name's Alasdair Rutherford. I'm a senior lecturer in social statistics in the School of Social Sciences. And I'm going to talk about data visualization, producing graphs and charts to show your data. You'll be learning about different measures, different ways of describing data, different ways of looking at associations. And I want to talk about how you might present those and visualize those for a number of different purposes. And this really combines some statistical understanding of how you collect data, how you analyze data, how you interpret data, along with some principles of design and communication about how you explain the story that comes from your data, how you talk about the findings. So I'm going to talk about what data visualization is and why we need it. We're going to look at some common graphs and charts and common ways of presenting data, some of which will be familiar to you already or you'll have seen around. I'm going to talk a little bit about some of the developments in data visualization, some of the newer forms of visualization. Look at how you choose the right visualization, what are some of the issues you need to think about in presenting your data visually. And then lastly, finish up with some examples of the dark side, how visualization can mislead. So when we're presenting data, it's not just about pretty pictures or about replacing a table with a chart and introducing some color. It's about thinking a bit about how best to present complex data, the relationships that make up the findings and the conclusions that you're drawing from the data. And there's a number of different reasons that you might do this. So you might be wanting to summarize your data in the same way that you'll do some basic descriptive statistics to look at the average and measures of spread. When you're starting your analysis, you might want to take a look at the data and see what the distribution looks like. You might use visualization to start doing your analysis, to actually identify potential patterns. What sort of relationships between variables does it look like there are that you might then want to use some of your statistical tests to investigate? Once you've done your analysis, you're going to need to present your data. So you might use visualizations as a way to communicate the analysis that you've done and the findings that come from it. And then if you're building that into making a case, into demonstrating an argument, into presenting some findings, you might use the visualizations as part of telling a story of the findings of your data. Although there's been lots of recent developments in data visualization, it actually has a long history. One of the pioneers was Florence Nightingale. If you're interested in finding out more about that, there's a link to a short video on YouTube on the slides, which you can look at later. But Florence Nightingale used data visualization in the Crimean War. There was lots of statistical tables about the deaths of soldiers. That was obviously important, had an impact on large numbers of people. And she used some clever visualization to show that the death rate was far higher among soldiers that were in hospital and from preventable diseases and injuries rather than on the battlefield, and used this to make a case for better hygiene and cleanliness standards in hospitals, that was going to have a bigger impact on people surviving. And to show the size of these effects, she used graphs and visualization rather than just presenting statistical tables in order to tell that story and to make that case. So there's lots of different visualizations you can use. I'm going to talk briefly about some of the more commonly used ones: bar charts, line graphs, pie charts, scatter plots, that are pretty typical, and you're likely to start producing yourself. And there are different ways to produce these sorts of graphs. Many of them can be produced in spreadsheet software such as Microsoft Excel, the statistical software, and then there are increasingly online tools that you can use to present data in interesting ways. So first of all, bar charts then. Bar charts are particularly useful for presenting categorical data. So data that is which category people are in. They present the categories along the x-axis, the horizontal axis, the bottom of the graph, and then the height of the bars usually tells us the averages, percentages, frequencies on the y-axis or the vertical axis. And one of the big advantages of a bar chart is that it shows you proportional as well as absolute differences. So you can see that some amount is twice as much as another because the bar is twice as big. So you don't just get a sense of the absolute value, but you get a sense of the relative values as well. So this is a graph of Twitter activity by day of the week. So we've got categories here, Monday to Sunday, and we've got the percentage of tweets on that day. And it gives you some sense of this pattern. There's not a lot of variation, but there's the highest number of tweets on a Tuesday and Wednesday, and it's the lowest on a Sunday. Okay, so we get some sense of spread across the week, rather than just presenting it in a table. Our categories are on the x-axis, the percentage of the activities on the y-axis, and that communicates the spread. Okay, we might also have more continuous data, particularly if it can be grouped on the x-axis. So, for example, years of age. Age is a continuous variable, but if we think about it as age in years, we can treat it as categories. We can look at the percentage of Twitter users in each age. So we've got age categories here. There's an ordering to them, and the height of the bars show the percentage, so that we can see that the bulk of Twitter users are sort of 20 to 25, but there is a long tail here of older users of Twitter as well. So we get some sense of both the kind of middle of this distribution and also the spread of the distribution, how variable it is, how likely it is to see different values. So we'll quite quickly communicate that spread of our data. And in this bar chart, the categories here are ordered. You're getting older as you're going to the right. Line graphs are mostly used to present continuous data or metric data, where we have a variable that's not in categories, but it's a continuous quantity. Although they can be used for ordered categorical data, but that makes the most sense when it's approximating an underlying continuous variable. And it's best when you want to show changes across the values of the x variable. There is lots of data that you could choose between a bar chart or a line graph. The line graph is best when there's some ordering to those values and maybe perhaps some sense of change across those values that you want to capture. So this shows the average number of tweets per day by how many followers the users on Twitter have. And so we've got some sense of movement. As the number of followers increases, how does the frequency of tweeting change? So we can see for people up to about 800, 900 followers, it's pretty flat at around 3 tweets a day. There's not a lot of variation. When people get above 1,000 followers, these are the accounts that are tweeting much more frequently, and then it climbs after that. So we get a sense of this shape and this change across the number of followers. Okay? And it gives us some sense of a trend across that data. Pie charts then are a common and accessible way to represent percentages and proportions. So rather than absolute values, what percentage of the sample do the different values make up. They need to be used with categorical data because you need each slice of your pie to be a category. The categories don't have to be ordered, but they do have to be mutually exclusive. So everybody has to be in one category or another. The pie chart isn't going to work if people can be in more than one category. So your percentages have to add up to 100%. So this is the Twitter users by age group. You can see from the key the colors that apply to the ages, and this is the percentage. So the percentages add up to 100 and make up the whole pie. Okay, so the area of the segment represents that percentage. And when the data is ordered, it can be easier to see combinations. So, for example, the blue and the red here is telling us the percentage that are between 15 and 24. We can sort of add them up. We can see that that's about 2/3. So when there is an ordering to the categories, that can be helpful in reading sort of groups of categories from the pie chart. It's not going to work so well when you want to compare, the size of this slice to a slice that's not next to it. If they're not, it can be difficult to judge that area, and that's one of the drawbacks of a pie chart. Our fourth graph type then is the scatter plot. Scatter plots allow you to compare the values of two variables, and specifically metric variables, so that are interval or ratio, that are continuous data, And so rather than just describing one variable, they're useful when we want to look at potential relationships between those variables and look at those patterns, which we might then go on to test with some of our statistical and inferential tests. And they're also useful for spotting outliers, cases that don't fit the pattern, that are quite different, and that we might then want to understand why those cases are different. So here's an example of scatter plot of spouse age. So this is the age of the wife. This is the age of the husband. This is data from the British Household Panel Study from 2008. And so each dot here is a couple, and you can read off the age of the wife and the age of the husband from the position of the dot. Okay, so first of all, it gives us a good sense of a trend here that ages tend to be fairly similar in married couples. People that are older tend to have an older spouse, but also that there's quite a bit of variation around that as well. So we can see some outliers, for example, a particularly old husband and a particularly young wife. There are a number of couples that are away from this trend. So here we can see quite a strong relationship with this. As we would expect, there's quite a strong correlation, but also get some sense of the variation around that association, and look at outliers as well, which might be genuine outliers or might also be coding or data entry issues. And then lastly, combining some of these ideas are our box plots that give us quite a lot of information about our data. So it shows you the proportion in different quartiles, splitting the data up into 4, and also gives us different measures of the middle of the data and lets us compare distributions. So we'll typically have a box plot like this. The shaded box here is the 25th to the 75th percentile, so a quarter of the data is below here, a quarter of the data is above here. So of course this is half the data in here, so that gives you a sense of where the middle half of the data is. It shows you where the central value is, the median, and also where the average, the mean, is as well. And then these whiskers give you some sense of the more extreme values of the data, and then individuals that are right outside that range are often marked as outliers as well. So this gives you a sense of the spread, because the bigger this central box here, the more spread out the middle of the data is. The further out these whiskers are, the further away the outliers are, the edges of the data are, and then it also highlights particular outliers. So it's got a lot of information in the one graph that can help you understand the center, range, and spread of the data. You could then combine those into a more complicated graph where you're comparing values across different categories. Okay, so you're able to see that for different countries, not just the averages are different, but the spreads are different, the ranges are different, and so you can use this in order to start looking at relationships, combining categorical and metric variables. So those are some of the traditional graphs that you'll see most commonly and that are generated by packages such as SPSS. With improvements in technology and more input from graphic design, as well as increasingly available data, allowing people to do more with open data, with data sources that become available. There have been a range of developments in data visualization and attempts to make data more accessible and the communication of findings from data more accessible. So we can look at some alternative variations. So this is an area plot, so it's carbon dioxide emissions. It shows you the carbon dioxide that was released up until the year 2000, the carbon dioxide added since 2000, how much more we could safely release without affecting the climate, the size of the fossil fuel reserves, and then the estimated remaining fossil fuel reserves that are undiscovered. And so you get a sense of the relative sizes here compared to the carbon budget is described, what's left to release compared to the amount of carbon that's left in the ground. So this, by using area and color, is able to communicate the relative sizes of these numbers more persuasively than just a table might on So it provides an alternative to the bar chart where we're not using height, we're using area. The advantage of area is it's quite easy to compare them. It's quite easy for our eyes to tell whether one area is bigger than another and make comparisons. And this visualization also includes the numerical data, so you can actually read off the numbers as well as getting a sense of their magnitude. Other graphics are incorporated to make some of the visualizations easier to understand. So this is looking at typical Twitter users. If the Twitter community were 100 people, so you could think about each person here as being like 1% of the Twitter population, because there are 100 people here, and then the color is used in groups to show the characteristics of that population. So we have 20% are dead, are empty accounts that aren't active. 50% here are lazy, they haven't tweeted in the last week. Only 5 have more than 100 followers. There are 5 loudmouths creating 75% of the tweets. So just 5% of the Twitter users are creating 75% of the tweets on the site. And then you could get some sense of the gender balance as well, perhaps. So this is kind of an alternative to a pie chart because it's giving us a proportion, but we can easily read off the percentages. And it's containing a range of information by the different combinations of the groups, and in quite an attractive and accessible way. So that's lots of different visualizations that we could think about. And so the question is, how do you choose what visualization to use? How do you know when to use a bar chart or a line graph or a pie chart or to do something more complex? And the 3 questions that I would suggest are important in making that decision are, firstly, what sort of data are you using? So some of the examples required categorical data or required metric or continuous data. Some of the visualizations are a combination of the two. So the type of data that you have is going to make some of that decision for you as to which visualization is appropriate. And that's true when you're choosing the statistical tests and the methods that you're going to use to work with your data. So it's really important to know what type of data you're working with. So that's going to be the first thing. Secondly, you want to think about what characteristics of the data do you want to communicate? Are you trying to communicate the absolute value of something, the total amount of carbon, or the number of people using Twitter? Or are you trying to communicate something relative? What percentage of Twitter users are female? How does the amount of carbon we've emitted compare to the amount that's left in the ground? And you're wanting to make a comparison between quantities or a relative message rather than absolute. Are you trying to communicate just the middle of a distribution? Do you just wanting to show the average, and so a bar chart just show an average? Or are you trying to show the shape of the distribution, so some sense of how similar or how different members of that sample are? So you need to think about what it is that you're trying to communicate. You use all sorts of different graphs, but what is it that you're trying to say with it? And then lastly, who is the audience? Because you want to produce a visualization that is understandable to the audience that you're trying to communicate with. So for a research audience, for an academic audience, then the box plot has a lot of information about the distribution, and you can read off really efficiently lots of characteristics of subgroups within a sample. But it is a little bit difficult to read if you're not familiar with a graph like that, and so it doesn't necessarily convey that information straight away to people who aren't used to reading graphs like that. So some of the visualizations we looked at the end can be more accessible, particularly in use of color and shape and area, that you can look at it and pretty quickly get the essence of what it's trying to say. So you need to think about who you're trying to communicate with, to ensure that the graph, the chart, the visualization that you use is able to convey the message you want to the people that are consuming it. Okay. So just like the numbers themselves, data visualization can be used to mislead, and this might be accidentally because you don't label the axes right, or you don't produce the right chart for the data that you have. Or there are also examples of data visualization being used to intentionally mislead in the same way as there can be with numerical statistics. You need to be particularly careful when you're using percentages, that you're clear when you report a percentage, what it is a percentage of. Is it a percentage of your whole sample? Is it a percentage of a particular category? Is it a percentage of people with particular combinations? Are the categories exclusive, so the percentages all add up to 100%, or can people be in more than one category, and so that doesn't make sense. And you also particularly need to pay attention to the scales in your graph. So the eye is perceiving shape, area, and color, and by changing the scale of your data, you can change how the relative sizes look. And so you have to make sure that you're picking an appropriate scale that is honestly communicating the underlying data and isn't being used to hide or conceal some characteristic of the data. So to sum up then, there's lots of different data visualizations available to use, from our sort of traditional bar charts and line graphs and pie charts to some of the more innovative area plots and data visualizations, and even dynamic visualizations that are interactive, that let you change things and see how the data moves if it's online. It's important to choose the right graph or chart in order to describe your data. So it's a really good way to get a sense of to get a feel for your data. So you're still going to want to produce the sort of summary statistics of the measures of the center, your averages, your measures of spread, and so on. But it's also a good idea to have a visual inspection of your data, to have a look at that distribution and get a sense of whether it's what you expect. Are there observations, are there outliers, are there values that don't make sense that you want to investigate further? Sometimes doing that visually can be more intuitive. You do need to choose the right graph or chart when you come to the presentation of your findings, or the telling of the story, of the writing up. There'll be lots of possible charts you could produce, and you need to think about which one tells your story, demonstrates your findings, and what type of chart is appropriate for the data that you have and the audience that you're trying to communicate. And lastly, you really need to be aware of misleading with your visualizations. Either intentionally or accidentally, particularly in your choices of scale and choices of percentages, because there are a number of traps that you can fall into. But thinking about some of these principles and about how your audience is going to read and interpret the graphs and the visualizations you produce can make the analysis and the presentation of your findings from analyzing data much more accessible, much more persuasive. And reach a wider audience to communicate what it is you've done and the findings that you have from the data that you've analysed.
Thank you for watching this ThinkData video. If you enjoyed it, please like and subscribe, and check out the other videos on our channel. For more resources helping third sector organisations to make better use of data, visit www.thinkdata.org.uk.